Okay, so I'm going to start recording the static equilibrium, friction, and tension problems. First one is about a hockey puck, and we don't know the mass of the hockey puck. It doesn't matter, it's going to cancel anyway. We know that it has an initial speed of 23.2 meters per second. We're going to bring it to a stop, so BF has to be 0 meters per second, and this is going to happen in a distance of 46.1 meters. They want to know what is the coefficient of friction. Well, we know that net F equals ma. The only thing stopping this hockey puck is friction, so friction is our net force. We also know that friction, and its kinetic, is equal to mu k times force normal. And we know that our hockey puck has a weight mg, force normal, and in this case force normal must be equal to mg. So then our frictional force is going to be mu k times mg. So now I know this expression for friction right here. I can use that. So if my net force is my friction, and my friction is mu k times mg, that's equal to ma, because net F is equal to ma. Those will cancel. So mu is going to simply be mu k, kinetic coefficient of friction, A over g. Well, I know g is gravity, but I need to get A. Well, I taught you a long time ago that Vf squared equals Bi squared plus 2Ad. So Vf squared minus Vi squared over 2D would give me A. So 0 meters per second squared minus, my initial is 23.2 meters per second squared over 2D is 46.1 meters, gives me A. So when I solve for A, I got, and this will be a negative because it's a decelerating acceleration, I got negative 5.83 meters per second squared. Now, I don't really care about the fact that this is negative, because what I could have done is up here I could have said that that negative frictional force, which is a retarding force, and so then mu k would have been, or a negative mu k would have been a negative A over g. So the negative sign doesn't really matter. So mu k is 5.83 meters per second squared divided by 9.8 meters per second squared. So those units should cancel. So mu k, when I did it, I got 0.596. Alright, the second one. Second question says you have this setup, and you have tension 1 and tension, oops, that's not very good. So let's erase that. Tension 2. And you have this angle is 20. And I believe this angle is 35. So my diagram's not really very good, but I think you can kind of get an idea. The one on the handout is much better. So I'm going to call that T2x, T2y, and then I have T1x and T1y, and then I have the sign, or the weight, hanging right here, and it's 1200 newtons. So what I know is that my horizontal forces T1x and T2x have to balance each other. They have to cancel each other out. One is to the left, one is to the right. So I'm going to say T1x must equal T2x. T1x is going to be the cosine of 20 degrees times the hypotenuse T1, and then T2x is going to be the cosine of 35 degrees, times T2. So T1 is going to be the cosine of 35 divided by the cosine of 20 times T2. And when I did cosine of 35 divided by cosine of 20, I got 0.872. So T1 is equal to 0.872 T2. Now I need to consider my y's, so T1y plus T2y, they're my only upward forces, have to equal my downward force of 1200 newtons. So the sine of 20 degrees T1 plus the sine of 35 degrees T2 has to equal 1200 newtons. Well, I can't go any farther because I have two unknowns, but I know that T1 in terms of T2 is written right here, so I can say the sine of 20, and instead of T1 I can put in 0.872 T2 plus the sine of 35 degrees T2 should equal 1200 newtons. So when I did sine of 20 times 0.872 T2, I got 0.298 T2. The sine of 35, when I did that, I got 0.574 T2. 0.574 T2 is equal to 1200 newtons. When I added those up, I got 0.872 T2 is 1200 newtons. So T2 wound up being 1200 newtons divided by 0.872. So I got 1376 newtons. If I looked at my sig digs, it looks like I have 2, so I would make that be 1400 in terms of the sig digs. And then I said, well, T1 is 0.872 times T2, so T1 is 1200 newtons. And I'm done. Alright, I'm going to do number 3. Number 3 says that you have a box, and this one's rather interesting. You have to pay attention very closely to the force normal. And you have some tension in the rope. And there is an angle that this rope is being held at, and it's 32 degrees. And so you have Tx, and you have Ty, and then you have the weight, which is mg. And my mass was 18 kilograms, and my gravity is 9.8, so I multiplied 18 kilograms times 9.8 meters per second squared. And when I did that, I got 176.4 newtons. Then I said, I know there has to be a force normal, and then there has to be some friction here. So if net F is equal to ma, I have Tx to the right, friction to the left, so I'm going to make it negative, is equal to ma. So Tx minus F is 0 because it's not accelerating, is what it told me. Now it's moving because they give me the coefficient of kinetic friction. It's just moving at a constant speed. Well, I know that Tx is the cosine of 32 degrees times T. And I know that the friction is mu times the force normal. Be careful with this force normal. The force normal plus Ty have to add up to W. So the force normal is the weight minus Ty. The weight is 176.4 newtons. Ty is going to be the sine of 32 degrees times T. So now I can go make some substitutions. So Tx was the cosine of 32 degrees T. And that has to equal friction, which is mu times force normal. Force normal is 176 newtons minus sine of 32 degrees T. Well, I know that mu is actually given to me, and the mu value is 0.45. Should have listed that with my givens over here. And I'm looking for this tension. So now I have cosine of 32t, and I got 0.848 when I did the cosine of 32, is equal to 0.45 times 176 newtons minus the sine of 32t. The sine of 32t is 0.5299. So I had 0.848t. I multiplied 0.45 times 176, and when I did that, I got 79.38. And then I multiplied 0.45 times 0.5299t, and when I did that, I got a negative 0.2385t. I brought my t's together by moving this over to here, and when I did that, I got 1.0865t is equal to 79.38 newtons. I divided both sides by 1.0865. That'll cancel. And then I said, well, if I do the algebra correctly, 79.38 newtons divided by 1.0865 gives me a t value that is equal to 73.1 newtons. And when I looked at the sig digs, I think there were 2 of them, so that was 73 newtons for the tension. Okay, I'm going to stop this one and make another one.